Generally, it is not acceptable to perform work on live components within electrical tap boxes unless specifically permitted by recognized electrical codes and standards such as NFPA 70. Electrical work involving live components should always be performed while wearing appropriate personal protective equipment, including arc-rated clothing, insulated gloves, and a face shield. Safety glasses alone do not provide sufficient protection. Implement a procedure that prohibits working on live components inside tap boxes. Instead, isolate the circuit by cutting power and verifying the absence of voltage before performing any work. It is generally permissible to penetrate an MCC while it is energized if certain safety precautions are taken. Ensure that the penetration point is at least 12 inches, which is about 30 centimeters, from any exposed live parts. Use insulated tools and ensure that any exposed conductive surfaces are covered. Monitor the area for smoke, sparks, or other signs of a potential fault. Have a qualified electrician supervise the work and be prepared to de-energize the MCC if necessary. Conduct a thorough risk assessment before performing any penetration work on an energized MCC. Consider factors such as the voltage, current, and the proximity of live components. Establish clear policies and procedures for electrical maintenance and repair. Train all electricians on proper safety protocols and code requirements. Implement regular inspections to ensure compliance with safety regulations. Regularly review and update safety procedures based on industry best practices and lessons learned from incidents. When dealing with electrical work, especially in potentially hazardous environments like tap boxes and motor control centers or MCC, adhering to established safety protocols and recognized electrical codes is paramount. Failing to do so can lead to severe injuries, equipment damage, and costly downtime. Let's delve into the specifics of the two scenarios presented: the tap box incident and the MCC penetration, to provide a comprehensive understanding of the safety measures required. Firstly, the tap box incident. The situation described involves an electrician working inside a 6-inch by 6-inch by 4-inch tap box containing live 600-volt wires. The electrician was pulling wires to change a feed to an existing machine, intending to complete the connection once the power was shut down in a few days. Unfortunately, while pulling the wires, a wire nut came off, causing the machine to shut down. Thankfully, no one was injured. This incident raises serious concerns about code compliance and safety practices. Generally, performing work on live electrical components within tap boxes is not acceptable unless specifically permitted by recognized electrical codes and standards. NFPA 70. Which is the standard for electrical safety in the workplace, provides detailed guidance on working with energized electrical equipment. It emphasizes the need for a comprehensive approach to safety, including hazard identification, risk assessment, and the implementation of appropriate control measures. In this particular case, working on live 600-volt wires inside a confined tap box without proper personal protective equipment or PPE represents a significant safety violation. Electrical work involving live components necessitates the use of appropriate PPE, including arc-rated clothing, insulated gloves, and a face shield. Safety glasses alone do not provide adequate protection against the potential hazards of arc flash and electrical shock. Arc-rated clothing is designed to protect against the thermal effects of an arc flash, while insulated gloves provide protection against electrical shock. A face shield protects the face and eyes from debris and arc flash exposure. To prevent similar incidents from occurring in the future, a revised procedure should be implemented that strictly prohibits working on live components inside tap boxes. Instead, the circuit should be isolated by cutting power and verifying the absence of voltage before any work is performed. This can be accomplished by using a properly rated voltage tester to confirm that the circuit is de-energized. Additionally, a lockout-tagout procedure should be implemented to prevent the circuit from being accidentally re-energized while work is in progress. Lockout-tagout involves placing a lock and tag on the circuit breaker or disconnect switch to indicate that the circuit is being worked on and should not be energized. Now, let's consider the second scenario, MCC penetration. Penetrating an MCC while it is energized is a common practice in many industrial facilities. However, it must be approached with extreme caution to minimize the risk of electrical hazards. While it is generally permissible to penetrate an MCC while it is energized, certain safety precautions must be meticulously followed. Firstly, ensure that the penetration point is at least 12 inches, or approximately 30 centimeters, away from any exposed live parts. This distance provides a buffer zone to reduce the risk of accidental contact with energized conductors. Secondly, use insulated tools specifically designed for working with electrical equipment. Insulated tools provide an extra layer of protection against electrical shock. Thirdly, ensure that any exposed conductive surfaces in the vicinity of the penetration point are covered with insulating materials. This helps to prevent accidental shorts or ground faults. Fourthly, continuously monitor the area for any signs of a potential fault, such as smoke, sparks, or unusual noises. If any of these signs are present, immediately stop work and de-energize the MCC. Lastly, have a qualified electrician supervise the work and be prepared to de-energize the MCC if necessary. A qualified electrician possesses the knowledge, skills, and experience to identify and mitigate potential electrical hazards. Before commencing any penetration work on an energized MCC, a thorough risk assessment must be conducted. The risk assessment should consider factors such as the voltage, current, and the proximity of live components. This assessment helps to identify potential hazards and determine the appropriate control measures to implement. One of the primary concerns when working near energized equipment is the risk of arc flash. An arc flash is a dangerous electrical explosion that can occur when a fault develops between two energized conductors or between an energized conductor and ground. Arc flashes can generate intense heat pressure waves and projectiles, causing severe burns, injuries, and even fatalities. To mitigate the risk of arc flash, it is essential to wear appropriate personal protective equipment, including arc-rated clothing, a face shield, and insulated gloves. The level of PPE required depends on the potential arc flash hazard, which is determined by the voltage, current, and clearing time of the circuit. The NEC, which is the National Electrical Code, provides guidance on determining the appropriate PPE for various electrical tasks. In addition to PPE, other safety measures can be implemented to reduce the risk of arc flash. These include increasing the distance between the worker and the energized equipment, using barriers to shield the worker from the arc flash, and reducing the clearing time of the circuit. The clearing time is the time it takes for the circuit breaker or fuse to interrupt the fault current. A shorter clearing time reduces the amount of energy released during an arc flash. Another important consideration when working near energized equipment is the risk of electrical shock. Electrical shock occurs when a person comes into contact with an energized conductor and provides a path for current to flow through their body. The electrical shock can cause muscle contractions, burns, cardiac arrest, and death. To prevent electrical shock, it is essential to maintain a safe working distance from energized conductors, use insulated tools, and wear insulated gloves. The safe working distance depends on the voltage of the circuit. The NEC provides guidance on determining the safe working distance for various voltage levels. Grounding is another critical safety measure that helps to prevent electrical shock. Grounding provides a low-resistance path for fault current to flow back to the source, causing the circuit breaker or fuse to trip and energize the circuit. All electrical equipment should be properly grounded to ensure that fault current can flow safely back to the source. Grounding conductors should be sized according to the NEC requirements to ensure that they can carry the maximum fault current. In addition to the specific safety measures discussed above, it is essential to establish clear policies and procedures for electrical maintenance and repair. These policies and procedures should outline the steps to be taken before, during, and after any electrical work is performed. All electricians should be thoroughly trained on proper safety protocols and code requirements. Training should cover topics such as hazard identification, risk assessment, personal protective equipment, lockout-tagout procedures, and grounding. Regular inspections should be conducted to ensure compliance with safety regulations. Inspections should be performed by qualified personnel who are familiar with electrical codes and standards. Safety procedures should be regularly reviewed and updated based on industry best practices and lessons learned from incidents. This ensures that the safety procedures remain effective and relevant. The NEC is a comprehensive set of standards that governs the safe installation and maintenance of electrical systems. It is updated every 3 years to reflect changes in technology and industry best practices. All electrical work should be performed in accordance with the NEC requirements. NFPA 70 E is another important standard that provides guidance on electrical safety in the workplace. It covers topics such as hazard identification, risk assessment, personal protective equipment, and safe work practices. All electrical workers should be familiar with the requirements of NFPA 70. In summary, working with energized electrical equipment requires a thorough understanding of electrical hazards and the implementation of appropriate safety measures. By following established safety protocols, using proper personal protective equipment, and adhering to the requirements of the NEC and NFPA 70, the risk of electrical injuries and fatalities can be significantly reduced. Remember, safety should always be the top priority when working with electricity. Never take shortcuts or compromise safety for the sake of convenience or speed. If you are unsure about any aspect of electrical safety, consult with a qualified electrician or safety professional. Firstly, consider the specific context of the tap box incident. The electrician's intention to pull wires in a live tap box, even with the plan to de-energize the circuit later, exposed him to unnecessary risk. The fact that the wire nut came off, causing a machine shutdown, is a clear indicator of the potential for more serious consequences such as electrical shock or arc flash. Secondly, it's crucial to emphasize the importance of proper planning and preparation before undertaking any electrical work. This includes identifying potential hazards, assessing the risks, and implementing appropriate control measures. In the case of the tap box incident, a proper risk assessment would have highlighted the dangers of working on live wires and would have led to the decision to de-energize the circuit before commencing any work. Thirdly, the use of appropriate personal protective equipment is non-negotiable when working with electricity. As mentioned earlier, safety glasses alone are not sufficient protection against the hazards of arc flash and electrical shock. Arc-rated clothing, insulated gloves, and a face shield are essential for protecting workers from these hazards. Fourthly, the incident underscores the need for robust lockout-tagout procedures. Lockout-tagout ensures that circuits are de-energized and cannot be accidentally re-energized while work is in progress. The procedure involves placing a lock and tag on the circuit breaker or disconnect switch to indicate that the circuit is being worked on and should not be energized. Fifthly, when it comes to MCC penetration, the 12-inch clearance rule is a minimum requirement, not a guarantee of safety. The actual safe working distance may be greater depending on the voltage, current, and configuration of the equipment. It's always best to err on the side of caution and maintain as much distance as possible from energized parts. Sixthly, the use of insulated tools is another critical safety measure when working near energized equipment. Insulated tools are designed to prevent electrical shock in the event of accidental contact with a live conductor. However, it's important to regularly inspect insulated tools for damage and replace them if necessary. Seventhly, continuous monitoring of the work area is essential for detecting any signs of a potential fault. Smoke, sparks, unusual noises, or any other abnormal conditions should be immediately investigated and addressed. If there is any doubt about the safety of the situation, work should be stopped immediately and the circuit de-energized. Eighthly, qualified supervision is crucial for ensuring that electrical work is performed safely and in accordance with established procedures. A qualified supervisor has the knowledge, skills, and experience to identify potential hazards and ensure that appropriate control measures are implemented. Ninthly, regular training and refresher courses are essential for keeping electricians up to date on the latest safety protocols and code requirements. Training should cover topics such as hazard identification, risk assessment, personal protective equipment, lockout-tagout procedures, grounding, and arc flash safety. Tenthly, the implementation of a comprehensive electrical safety program is essential for creating a safe working environment. The program should include clear policies and procedures, regular inspections, training, and ongoing review and improvement. By implementing these measures, organizations can significantly reduce the risk of electrical injuries and fatalities. Remember, electrical safety is not just a set of rules to be followed. It's a culture that must be embraced by everyone in the organization. It requires a commitment for management to provide the resources and support necessary to ensure a safe working environment. It also requires a commitment from workers to follow established procedures and to speak up if they see something that is not safe. By working together, we can create a safer working environment for everyone. Also remember that in the 2017 NEC, Section 110.4 discusses the integrity of electrical equipment and connections. It states that electrical equipment shall be installed and used in accordance with the instructions included in the listing and labeling. This means that any modifications or alterations to electrical equipment must be approved by a qualified engineer or testing laboratory. Section 110.12 addresses the neat and workmanlike manner of electrical installations. It requires that electrical work be performed in a neat and skillful manner with proper support and protection for conductors and equipment. This section also prohibits the use of damaged or deteriorated equipment. Section 110.13 covers the mounting and cooling of electrical equipment. It requires that electrical equipment be mounted securely and in a manner that allows for adequate ventilation and cooling. This is important for preventing overheating and premature failure of equipment. Section 110.14 addresses the electrical connections. It requires that electrical connections be made with approved connectors and in a manner that ensures a reliable and secure connection. This section also prohibits the use of improper or substandard connectors. Section 110.16 discusses the arc flash hazard warning. It requires that electrical equipment be marked with a warning label indicating the potential for arc flash hazards. The label should include information such as the voltage, arc flash boundary, and required personal protective equipment. Section 110.21 covers the marking of electrical equipment. It requires that electrical equipment be marked with the manufacturer's name, voltage, current rating, and other relevant information. This information is essential for identifying and maintaining electrical equipment. Section 110.22 addresses the identification of disconnecting means. It requires that each disconnecting means be clearly identified to indicate the equipment it serves. This is important for preventing accidental disconnection of critical equipment. Section 110.24 covers the available fault current. It requires that the available fault current at service equipment be determined and documented. This information is essential for selecting appropriate overcurrent protection devices. The NEC also contains specific requirements for working on energized equipment. Section 130.1 of NFPA 70. He addresses the requirements for working on or near energized electrical equipment. It requires that the qualified person perform a risk assessment before commencing any work on energized equipment. The risk assessment should identify potential hazards and determine the appropriate control measures to implement. Section 130.2 covers the personal protective equipment requirements for working on or near energized equipment. It requires that workers wear appropriate PPE, including arc-rated clothing, insulated gloves, and a face shield. The level of PPE required depends on the potential arc flash hazard. Section 130.3 addresses the approach boundaries for working on or near energized equipment. It establishes minimum approach distances for unqualified persons and qualified persons. The approach distances depend on the voltage of the equipment. Section 130.4 covers the electrical safety work practices for working on or near energized equipment. It requires that workers follow safe work practices such as using insulated tools, maintaining a safe working distance, and avoiding contact with energized pots. By following these NEC and NFPA 70 requirements, organizations can significantly reduce the risk of electrical injuries and fatalities. It is important to stay up to date on the latest codes and standards and to implement a comprehensive electrical safety program.